Okay, good morning. Welcome to lecture 45 on thermodynamics of materials. Today we have actually lost a good amount of time, so we'll try to do as much as we can with the remaining time. So first of all, please concentrate this. Last day, two relations I have picked up from last day's discussion. It is dG is VdP minus SdT and dA is minus PdV minus SdT because I have considered because the corresponding Maxwell relations are this del V del T at constant pressure is minus del S del P at constant temperature. Del P del T at constant volume is minus del S del V at constant temperature. We have already discussed this. So remember we have completed. So last class we have showed what you showed. Tell me what you showed. Directly this effect of pressure. So I don't go back to this, but I will only say this is nothing but minus alpha B. Alpha is the coefficient of expansivity. Last day. And del H del P at constant temperature was also V times 1 minus alpha T. These two we get. So today what is remaining? Obviously entropy, enthalpy. Then what remains? Gives free energy. So how entropy changes with pressure under isothermal condition and enthalpy changes with pressure under isothermal condition. These are the results. Remember, these effects are small. I told you, effects are small. Effects are small. Why? Small in both cases. Why small? Because what is the reason? Because what I said, effects are small, and also it demonstrated with problem. Effect of pressure 490, then it causes same change in entropy as is caused by only how much of temperature change? 30 degrees, okay, or 20 degrees. So this problem you have, last class problem. Okay, you remember this? I discussed this. Assignment number 20 degree Kelvin. Just 20 degree Kelvin does the same thing on entropy as done by enthalpy as done by 494 atmosphere pressure or 494 times increase in pressure. So means effect is very small. Pressure effect is very small compared to the temperature effect. So effects are small because what is the reason? Because this V is small. V is the smaller molar volume, because the molar volume small. This I said already, because the molar volume V is small for solids. V is small for solid. Effects are because volume V is small right here for solids and liquids. Condensed phases, which is called condensed phases. Liquids. Sorry. Now what is remaining? Del G by del P. Next, today we start. As if we start today. What is del S del P? Del H del P. What is del G del P? Let us complete this. Then we will be all set. G is H minus Ts. Remember. What is this? Del P. G is what? H minus Ts. Give this under constant temperature. What you will get? Obviously, del H del P at constant temperature minus T is constant, P outside. Del S del P at constant temperature. What you get from this? This is V times 1 minus alpha T minus this is minus alpha B plus and minus T. So plus alpha Vt. If you do this, you will get V. So effect of V. So del G del P at constant is again molar volume. Again molar volume. Or just directly molar volume. So effect is small still. Yeah, okay. Here also. So effect is small. So these are the three things that you learn today: del S del P, del H del P, del G del P. Again, for solids, small. Actually, do you have any other source to answer this without doing this? Any other source? The del G del P at constant temperature is volume. So we did this. This is correct. Any other source here on the blackboard? On the board? Anyhow, is written. First line. So we knew the answer. It's kind of cross check. Consistency. You see this point? Okay. So this is your del G del P. Okay. That is del G del P at constant temperature is V. So here also. So cross check. Also from this equation 1. Okay, this fine. This is can be obtained. Next is Cp minus to show Cp minus Cv. Okay. Okay, to find the general expression for Cp minus Cv. Just what is Cp minus Cv last time you got? When you left off, what is the Cp minus Cv last time? You find general expression for Cp minus Cv, okay? Or now P plus, that is for ideal special case, general. P plus, see these discussions that I am making all for fixed mass fixed composition, okay? Any system, any. P plus del U del V at constant temperature, recall, Cp minus Cv and del V del T at constant pressure, recall. Acha. General is okay. Leave it there. So what is this? This will left off. For ideal gas, this is 0. So P del V del T at constant pressure, this is R by P, so R. This was shown when it was discussing Cp minus Cv. But this was the relation general. This was actually general that time, but we can further work on this today with the help of this. So P plus del U del V, apply this. First law or what relation you have? Can I write another one in case it helps you? Du is what? There are four. Du is last day. Can anyone tell me what is du? This way, du is dq minus d double. You know, examination syllabus. This was syllabus. Du is dq minus d double. dq reversible is TdS. dw reversible is, it is so easy. I said you find for reversible, that will apply for irreversible also. So this, so I am returning this. So du is TdS minus PdV. Or you get this. Or del U del V at constant temperature is what? T del S del V at constant temperature minus P. Now apply Maxwell. I tell you, these Maxwell and these two are very important. I said other are of academic interest. So at least I didn't get much practical, but these two are practical. One already have seen. This will be used now. What is the del S del V? What is this? Minus, write that. What is, maybe you have not checked this. This is wrong. Can you tell me figure out what is the error? This line. Error? Maxwell. What it be the wrong? Error. Del P by del T at constant volume. Del S by del V at constant temperature. So it looks good. Minus should be plus. Minus should be, that's right. So what it will be from this? So substitute here. So del S del V is T del P del T at constant volume minus P. Okay? Is okay. This is. Or what you have? What you have here? P plus or P plus del U del V at constant temperature is what? T del P del T at constant volume. So give me equation number 1. So from 1 what you get? So from 1 return to 1. So this is nothing but Cp minus Cv is T del P del V. Okay, what is this? T what P plus dU is what? T dP dt at constant volume. You have not said. T dP dt at constant volume. Take a look here. P plus this is T this term. So what is this? This is T del P del T at constant volume times del V del T at constant pressure. Now you see, this is measurable thing. This is expansivity, physical significance. Del P del T, how pressure changes the temperature volume, we will actually recast it in practical forms or convenient forms. What is this? Okay, this is what, I tell you what, I am writing in some form, then I will explain you. When I explain you, is what? Del V del T, this is equals to del V del T at this part, or only this part. Del V del T at constant pressure, quickly. Only 3 or 4 steps away. What you follow? You knew this perhaps, but you follow only this is nothing but del V by del P at constant temperature. You check this. And times, I am removing this. These are all over. These are all over. Is all over. Okay. So what is this? Times del V del T at constant pressure. Take a look. Now, is it correct? How it is correct? Even I tell you. This is written as this is called transformation formula. Very important for this, all these derivations. Also proofs, okay? Prove this. You have in the assignment number 5, there are 3, 4, that you apply this frequently. And Maxwell relation frequently, I tell you. Maxwell relation and this. What is this transformation formula? I will prove this. This is actually your first year, or maybe I don't know, high secondary, I don't know. What is this? There should be a minus sign. Follow. How, see, you see this. Del V del T as if, quickly. Del V cancel. So it is dP del P del T back. Correct. It is with 3 variables, P, V, T, X, Y, Z, M, N, P, H, U, G, 3 only, not 4, neither 2. So P, T, V, how you rearrange this? Del V, del T, del V, such that as if you divide, as if dB cancel, return to del P, del T. But what you attach here, note, so here see PT, V. So it will be VT, the third, VT, P constant, the VP, P constant. This is called transformation formula. You have to frequently use this. I could have said some questions today's exam, but I didn't because it was not discussed. Okay, so that's I didn't set this question. There are some proofs actually using transformation formula and Maxwell. Okay, you have to learn how it is used. I am showing this. This I am proving to you quickly. Proof. Let me know. Proof for transformation formula. This is your first year mathematical exercise, okay, purely mathematical. Transformation formula. What is this you follow? Suppose three members only. Suppose Z is a function of x, y. What is dz? Right? Del z by del x, constant y times dx, plus del z by del y, constant x ty. Happy? Then as if you are considering under constant z. Under constant z, I have a process under constant z. Then what will be? Dz will be left hand side 0. Del z del x y. This will be what? Dx under constant Z, the change is under constant pressure, constant temperature, constant Z, plus del Z del Y under constant X times, can I remove this little bit from 1 to help me, dx Z. So 0, or you are getting what? You can rearrange this, okay? Now this dy, tell me, dy Z. What you are getting from this? Del Z, right? Side change. Del x, del y Z. Take it this side is minus del Z, del y x. Take a look. Okay? Happy? This is. One goes to the other side, and dy is you're dividing by dy. So del x, del y dz. Or you are getting what? You mark this. Del x, del y z, cyclic. Then next you take up del y times del y, this one, this side. Del y, del z, x, x, y, z, y, z, x. And then last is del z, del x, y is, when you multiply by the 3, what remains? 1, minus 1. This is your famous transformation formula. Okay, this I have used. This says what? I tell you what? This if you see, you try this, what you see here also, see here. So as if, how you getting? As if, del x cancel, then what? dz dy, dz. Only remember, here constant will be what? Zx, other will be, third will be constant, y. Here xj, xy, what will be the constant? Z, zx, zy, x. So this is xy, z constant, yz, x. So these things, because these are number of manipulations are there. I will solve some problems today, time, but we are very close to formulating Cp minus Cv. What is this? Then continue is what? Continue accepting this part is minus T del B del T constant pressure. Del B del T at constant pressure is squared by del B del T at constant temperature. See, now tell me what is this? Minus T. What is alpha? Recall. Alpha is what? Alpha is 1 by V del V del T at constant pressure. And recall likewise beta. Beta is what? Minus 1 by V. Minus 1 by V del V del P at constant temperature. These two. Okay, so you substitute, apply this. Del B del T at constant pressure is what? Alpha V. So and squared is alpha V squared. And what is this? Underneath del B del P. Del B del P is nothing but beta V with negative sign. Do that. Beta V with negative sign. So what you are getting from this? Right? Minus cancel. Sorry. What do you mean? 1V cancels TV alpha square by beta. This I gave you, today is proved as if. Proved. Why? Because we already stated this. Cp minus Cv. When I taught you Cp and Cv, there I said Cv is difficult to determine for solids. Constant volume difficult. Impossible. So use this formula. Cp measurable. You measure Cp and Cp minus Cv. Cv is obtained from this using this relation. These are measurable quantities. So let me write here freshly. So what is Cp minus Cv? So let me write here somewhere. Okay. So we get where? Start this once more. Over. This is over. So I am removing this line. So what we get? So you obtain. So Cp minus Cv is Tv alpha square by beta. Box this. So you can use this to find one when the other is, like Cv you can find from 5 minutes. Okay, over. This part is over. So this I intended to discuss. Quickly take up. Next is assignment number last is 5. So which is due. So I could not ask anything from your assignment 5 because it was not. I didn't ask actually anything from this. Okay, 5. Assignment 5. Quickly, let us see at least one problem to one problem. Problem 1. Quickly. What is the problem 1? Problem 1, assignment 5. Starting with DH is TDS, another this fixed mass fixed composition relation last day we showed. With DH is TDS, anyone remembering? Plus VDP, so that for, you try the others, next class. Okay. So that for n moles of ideal gas, okay, what? N moles of pure substance, no, not ideal, of pure substance, what is to be proved? At a constant pressure. So remove this, these are all over. Remove this, at a constant pressure, pH is at a constant pressure, DH is NCP/dt. See, you know this. DH is NCP/dt, you know, but today you try to prove in a different way. For TDS plus VD. Playing with this number of ways you try to get the answer. So NCP/dt, you know, under constant pressure, dq is under constant pressure, Cp, dq is Cp/dt, NCP/dt, and dq and dh same constant pressure. Easy, quick. So you know this, but start from this. Let us see how we can. So prove. Answer. The solution. DH is what? Tell me. Right, TDS? Just this problem will stop. Just this problem. So DH is TDS. Now under constant pressure, tell me. DH under constant pressure is what? TDS, VDP is out. DS under constant pressure, you know. What is this? DS under constant pressure is what? Tell me. DS is under constant pressure is dq reversible by T. Under constant pressure is T n Cp/dt. Under constant pressure by T. Or you can do this. How do you do this? Okay. Let us see how I deal this. Let us see. Is okay. NCP/dt. Achha, note this. Note these two relations. Note. See, DS to Cp. Hello, what are you doing? DS to Cp. Quickly follow this. DS. Follow. DS is what? DS is dq reversible by T. DS is what? dq reversible under constant pressure, or DS constant pressure, apply constancy, is what? N Cp dt by T. Follow under constant, under constant pressure, right under constant pressure. You as if apply this under constant pressure. Quickly, NCP/dt. So, or this dt you can write actually under constant pressure. This change under constant pressure, then you have all set. Or ds by dt at constant pressure is n Cp by T. Take a look. This relation. Or Cp is what? N Cp by T. Okay, this is ds dt at constant pressure is n Cp. Or ds is what? NCP, tell me, NCP dt by T. ds to Cp. This also box. Under constant volume, what will happen? Tell me quickly. One quick journey. Link up ds Cp, and Cp ds. Now suppose from CP to DS, what you will do? Acha, I am doing this. Next is, acha, next, quickly. Next, CP to DS. How do I proceed? CP is what? You know. Start. First principle. Del Q, del T, constant pressure. Time over. Del Q, del T at constant pressure. Over. Okay. Del Q is what? Del H by del T at constant pressure. Del H under constant pressure is what? TDS plus VdP means VdP plus VdP out by del T. So you gave T del S. So dH is dt at constant pressure. Del S. This is also constant pressure. So you see, you get the same result. CP is T del S del P at constant pressure. CP from here, CP also. And CP I have given for 1 mole. This is actually for 1 mole I have given. Okay. So for 1 mole, write this. Del S del T at constant pressure is Cp by T. Or Cp is this. Okay. See, from this you can get or Cp or ds is Cp by or ds is Cp dt by T. Now quickly, I don't write this. You answer me. Under constant volume, I don't apply constant volume. What change you will get this? Under constant volume, quickly. Under constant volume, this is under constant pressure. Under constant volume, what it will be? And Cb dt by T. ds will be Cb dt by T. And del S del T, constant volume is Cb by T. So this. So under constant volume, similarly, start this. Similarly, I am writing you under constant volume, what is this? What change will be? DSV I am writing you. You develop. dq reversible is how much? See, follow. ds is dq reversible by T. Constant pressure. NCB dt. Change. What it will be? NCB dt by T. You will get this. You get what you will get? Or you get ds is here it is. NCB dt. This is constant volume. This constant pressure. This is constant volume. Okay. You can do this yourself. Okay. Or Cp will be what? Cb will be what? And Cb will be T here. You develop this last one. Del S, tell me, think about this. Cb, this Cb, all Cp constant pressure I have done. Upstairs to seminar. Look. Okay, I have stopped. Cb will be what? Tell me. Here. Cp is T del S del P at constant temperature. Applied constant pressure. You want to, under constant volume, what is the analogous relation? Constant volume? Cv. Cv is T del S. From here you get also. Cb is T del S del T. This is under constant volume. This dt now constant volume. This dt constant pressure. So Cb ds dt at constant volume. Okay, T times Cb is for 1 mole. This for n moles. For 1 mole or n moles. Over. Thank you. So with this, actually we have number of problems still remaining. Say 7 more problems. Next class will tomorrow. Tomorrow we'll first solve this, then other things. Okay. First place. This you try also home. See, read this problem. Okay, and come prepared. Thank you very much. With these words. Okay. We have actually completed lecture 45. Thank you.